Good morning to one and all. My name is Anupama. My registration number is 24BQ1A0492. Today, my seminar topic is random process. Firstly, we discuss about what is random process, different forms of random process, classification of random process, and deterministic and non-deterministic process. First of all, what is random process? A random process is a collection of random variables that change with time. In simple terms, it is a time varying random signal. Example, message signals in communication, background noise in a receiver, variation in weather like temperature or rainfall, speech or music signals. Why do we use random process? We use random process to study signals that changes unpredictably with time, such as noise or message signal. We cannot fully know their behavior, only their statistical properties like average power, variance, etc. can be known. Hence, they can be described statistically, not deterministically. The second definition, a random process is a time varying random phenomena described statistically using tools like PDF, small PDF, capital PDF, cross-relation, and covariance, which helps us understanding and model signals such as noise and message signals in the communication system. Random process definition. A random process is a process in which random variable depends on both time and sample space. So a random process is written as capital X of S comma T or simply X of T. Here S represent the randomness sample points. T represent time. That means for every random outcome yes, we get different signal functions of time. Different forms of random process. When time is fixed, you only looking at particular instead of time. The random process becomes random variable because only randomness remains represented as capital X of S comma T1. This shows the random value of the process at time T1. Example, noise voltage measured at one instant. The second one is when the sample space is fixed. You are looking at one particular outcome, one experiment. It becomes a real function of time, represented as capital X of S1 comma T. This means for one specific experiment S1, how the signal changes over the time. Example, the waveform of one realization of a random signal like one recording the noise. The third one is when both time and sample space are fixed. Both are given specific values, so it becomes a constant represented as capital X of S1 comma T1. Example, the value of signal at specific instant in one experiment. The different types of random process are simplified and given in the table. Conditions, representation, nature, example. Time variable, sample space, uh, sample space variable, time variable, sample space variable, x of s comma t. Random process, random signal. Time fixed, a capital X of s comma t1. Random variable, example, noise at a particular instant. Condition, sample fixed, representation, capital X of s1 comma t. Nature, time function, example, one noise waveform. The the next condition was both fixed, means time and sample space both are fixed. Then x of s1 comma t1 becomes a constant. Example, signal value or single value of signal. The next we discuss about the classification of random process. A random process can be categorized based on whether time and amplitude of random variable are continuous or discrete. Accordingly, they are divided into four main types. The four types of random process are continuous random process, discrete random process, continuous random sequence, discrete random sequence. Let us discuss first about continuous random process. A random process is said to be continuous if both time and the random variable are continuous over the entire duration. In this type, the random variable can take any value within a continuous range for all moment of time. An example is fluctuation of noise in an electrical circuit where both time and amplitude vary continuously. Here the graph was given to uh, to understand easily. Sample function of a continuous random process. Next, we discuss about discrete random process. In discrete random process, the random variable takes discrete values but time is continuous. The random variable can switch only between set and fixed levels while the time progresses continuously. For example, a digital signal that alternates between two discrete levels such as positive and negative levels but extends continuously in time. Here the graph was given to understand easily what is a discrete process. Sample function of discrete random process. The third one is continuous random process. A continuous random sequence occurs when time is discrete but the random variable is continuous. The random signal is defined at specific time interval but its amplitude can take any continuous value. It is represented as set of random variables defined only for discrete sampling instantaneous, such as t of k equals to 0, 1, 2, so on. This type is often used when sampling a continuous signal without quantizing its amplitude. The graph was given to understand easily or for the sampling function of continuous random sequence. The fourth one is discrete random sequence. In discrete random sequence, both time and random variables are discrete. The signal is sampled at discrete time interval and the amplitude is also quantized in discrete levels. This process is commonly used in digital signal processing. The amplitude may be represented using two levels or multiple quantized levels depending on the application. It is often obtained by both sampling and quantizing. Sampling means it is nothing but the process of converting a continuous time signal into a discrete time signal. Quantizing is nothing but decreasing the amplitude without changing the signal nature. The simplified table is given for the classification of the random variables. Type time variable, random variable. Example: continuous random process. In continuous random process, time is continuous and random variable is also continuous. Example: voice signal, thermal noise. In discrete random process, time variable is discrete whereas random variable is continuous. Example: daily temperature readings. The third one is continuous random sequence. In continuous random sequence, time variable is continuous whereas random variable is discrete. Example: switching between discrete state continuously. The fourth one is discrete random sequence where time variable is discrete and the random variable is also discrete. Example: digital data, coin tossing outcomes. Let us discuss about the another topic which is known as deterministic and non-deterministic process. Deterministic process. A deterministic process is one in which the value of signal can be exactly predicted at any instant of time. Once the mathematical expression it is known as describes it is known. Once the mathematical expression describes it is known. There is no uncertainty in the behavior of the signal. Every further value is completely determined by the known function or parameter. Example: x of t equals to 5 into sine of 2 pi 50t. A pure sine wave whose value can be computed exactly for any time. And the second example is x of t equals to 3t. The second one is non-deterministic process. A non-deterministic process, also called a random process, is one in which the value of the signal cannot be predicted exactly before it occurs. The signal contains uncertainty or randomness. Only the statistical properties such as mean, variance, correlation can be described, not exact values for non-deterministic process. Example: thermal noise in an electrical circuit, atmospheric noise in communication system, stock market fluctuation. Characteristic of non-deterministic process. Not exactly predictable, only probabilistic information is available. Describes using probability density function or statistical average. Each observation may differ even under the same condition. The simplified table is given for the deterministic and non-deterministic process. For deterministic process, completely predictable, has exact mathematical function, same output for same input. Example is 5 sine 2 pi 50t. Uncertainty, no uncertainty. For non-deterministic process, cannot be predictable exactly, can be represented statistically. Repeatability, different outputs even with the same conditions. Examples are thermal noise and random process. Uncertainty present, uncertainty present. That's it. Thank you.